Hey, what's up, everyone? For everyone who's new to the channel, my name is William, and this is my wife, Natalie. Everyone, welcome to the channel. So, I guess we could get started with the basics, I guess. So, the purpose of this channel is to basically debunk and expose the globe Earth lie using basic physics. So, the most simplest, most practical way, in other words. So there is the two top proofs, in my opinion, that completely destroy the globe Earth concept, and I'll go over them real quick for anybody who's new to this, and then we'll get on with the rest of the stream, I guess. So for one is we want to if we want to debunk the globe, we basically have to falsify the globe Earth. So the globe Earth makes a claim of gravity being a pulling force, and the globe Earth basically requires for people to believe in a force that accelerates all matter towards the center of a sphere, because that's how they explain the whole model, from orbits to day and night to even the spin of the Earth, and pretty much the whole model relies on that belief. So if we could debunk that belief, we can debunk the globe Earth model by default. So how do we debunk that there is no physical downwards acceleration of gravity or a force of gravity? It's simple. So gravity claims that when this object is at rest and you release it, that it accelerates down towards the Earth. So it goes from being at rest to acceleration after you release it. So if we understand basic physics and basic accelerometers, for that matter, accelerometers that detect acceleration, then we can prove or test to see if that's the case, to see if objects do accelerate in free fall. So this here will be considered a simple accelerometer. It's a container filled with water, and there's a buoyant object inside. It's a red plastic ball. So the red plastic ball is floating, you could say, in the water. It's being pushed up right now because of the buoyant force. So when it's completely at rest, once it's not moving anymore, and I accelerate it from being at rest in any direction, you can test this for yourself. The plastic ball is always going to react to the acceleration from being at rest. Doesn't matter the speed of the acceleration, the rate of the acceleration. In other words, there's always going to be a reaction to the acceleration. That is the third law of motion. For every action, there's an equal and opposite reaction. And this accelerometer was based on those principles, basically. It detects acceleration. That's what it is, will be considered an accelerometer. Another accelerometer will be this water bottle with air and water. Again, when you have two fluids, a liquid and a gas, in a container like this, and it's at rest, and you accelerate it in any direction, again, doesn't matter the rate of the acceleration. If you accelerate it in any direction, the water is going to reorientate relative to the direction of the force. In other words, the water is going to push back due to inertia in the opposite direction of the force, resisting the force, and pushing the air in the direction of the force. In other words, towards the front. So again, that happens 100% of the time. Even when I accelerate down, the water, resists the motion and pushes up in the opposite direction, pushing the air down. So, however, when we go into reality and we test to see if there is reaction to the acceleration in free fall, let me just show this. By the way, the link is there for anybody that wants to join anytime. If anybody wants to jump on, I can put a pause, whatever I'm doing, and we can have a chat. So just putting that out there, so anybody can join at any time. I can just put a pause to what I'm doing, and I'll come back to it after. So don't be shy to click the link. Let me go here. So again, when we go into reality to test to see if there's a physical downwards acceleration with simple accelerometers, again, we know the buoyant ball will always get pushed in the direction of acceleration 100% of the time. So here, the one on the right, you can see that when I actually accelerate it, it happens instantly. This is in super slow motion. This is in slow motion. And you can see the instant I accelerate, the instant I apply pressure, you can see the ping pong ball, the buoyant ball react to that pressure. What I'm doing here, I'm reorientating the pressure gradient, because the pressure gradient that's in the water, it's relative to the direction of the force, the direction that the push is being applied. So obviously, when it's just at rest on Earth, the ping pong ball is being pushed up, showing that the pressure gradient, the push, is coming from the bottom to the top. However, when I invert the pressure gradient, when I apply the pressure down, we can see that the density and buoyant effects of motion invert. The dense object moves to the top, and the buoyant object gets pushed towards the bottom, towards the direction of acceleration. So again, it detects acceleration instantly, in other words. However, in free fall, the one on the left, you can see that there is no reaction. There is no push. There is no pressure. There is no gradient, So in other words, it's not detecting any acceleration. The matter is not detecting acceleration in this one. That's why, gravity is just a theory, because there is no physical measurement of downward acceleration. There are no effects of acceleration in free fall, in other words. Let me share this one. Again, when it's air and water, again, the one on the right, when I actually accelerate, again, you can see the reaction of matter, the displacement. You can see the reorientation of matter when I actually accelerate down. The water wants to move to the top, pushing the air to the bottom. Again, the one on the left, no reaction whatsoever. But we're supposed to believe that this is accelerating at 32 feet per second. That's ridiculous. 32 feet per second, but yet no displacement whatsoever. And then the higher you drop this, that acceleration increases and still no displacement. So again, matter doesn't lie. Theories at the end of the day, or, man-made theories are the ones, it's what's actually lying. So that's the number one proof. Again, and what does that mean? Again, if we debunk the belief that it's the pulling force of gravity that's the cause to why objects appear to fall. But the fact is, again, if we can debunk that it's not a pulling force and its objects are not accelerating down, and it's actually the Earth moving up to the object. Because again, how do we know it's the Earth moving up to the object? Because again, buoyancy shows us the direction of the force. So again, the ball, it's showing us right now as I'm holding it on Earth, there's an upwards pressure being applied. Again, let me show this. I'm still sharing. Cool. Okay. Again, when connected to the Earth, we can experience a pressure gradient. Again, the less dense is being pushed to the top. Again, when connected to the Earth, as soon as I release that pressure gradient, that upwards push that's creating this effect of the slinky being stretched, that upwards push is no longer present in free fall. It completely vanishes, showing that there is no force, and the force is only present when connected to the Earth in the upwards trajectory relative to us. So again, if we could prove that it's not the objects accelerating down and it's the Earth pushing up, then if you're on a globe and and we know up is relative on a globe, because obviously depending on where you stand, up is always away from the center. So up is basically in every direction away from the center, pretty much. So if the Earth was moving up on a globe Earth simultaneously in all directions, how would that work? The fact is it wouldn't work, because that would mean that the Earth would have to be expanding and it would explode. So the globe Earth relies on the belief that objects accelerate down towards the Earth, because again, if it's the other way around, then the globe Earth concept couldn't even be taken serious, not even on paper, in other words. So again, that simple fact that accelerometers basically debunk physical downward acceleration, and buoyancy shows that it's the Earth's push that's creating the buoyant effect of pushing, less dense material up. That destroys the whole heliocentric model. Um, uh, Cover the number two proof. The number two proof, the globe Earth also claims to have satellites orbiting the Earth. So they need to know the radius of the Earth if they're supposedly going around it. So they do tell us the radius of the Earth is 3,959 miles. So what that means is that there has to be curvature every mile, and every mile it increases. So if we were to actually physically measure the Earth, in other words, the surface of water, because water, again, when containing at rest, doesn't matter the size, so it could be a lake, miles and miles across. The surface of water when containing at rest is always level, which is always horizontal, in other words. So they're trying to tell us that that surface of water is actually curving at 8 inches per mile squared. So let me just show this again for anyone who's new to this. Again, if anybody just joined the live, the link is in the chat. If you want to join me to have a conversation, if you think you can prove the globe Earth, or if you think you can prove the stationary flat Earth, or you have any questions about the motion of the Earth, or how the globe Earth is not a ball, and you just have any general questions and want to jump on, go ahead. The link is there. So just putting that out there again. See. So again, based on the dimensions of the Earth that they tell us, again, this will be the curvature formula. Based on the dimensions of the Earth, they tell us a radius of 3,159, and then the length we're observing of. And you can look at this formula. We can calculate for the curvature. So they're trying to tell us that in 3 miles, there should be 6 feet of curvature. So if we went to a lake, the surface of water, and we went to measure to see if that surface of water actually does deviate at the curvature rate they tell us, they're trying to tell us, this is what they're trying to tell us. If the level structure starts at 5 feet, and we extend that level structure, remaining horizontal over the body of water, in 3 miles, there should be a 6-foot deviation. So there should be an 11-foot gap at the end of the structure, the water deviating away from it. Well, we understand that the physics of water, always levels out once it's contained and at rest, especially. The surface of water doesn't have the physical ability to maintain a hump and increase, that curvature rate more and more every mile. That just defies physics. So again, understanding the physics of water, how it behaves when it's contained and at rest, shows that the globe Earth is a physical impossibility. The curvature rate that they show us doesn't exist. Water doesn't have the physical ability to do that. It's always a level when containing at rest, which is a horizontal. So, all right. So again, those are the 2 top proofs that debunk the globe Earth that a child can understand. So again, if anybody's having any issues understanding how the Earth cannot be a globe, or again, if you think you can prove the globe, it doesn't matter. You can join the stream and have a chat. Have a chat with us. I'm just gonna say hi to the chat real quick. Angela, Shifty Eye Shady, Earthship Bear. What's up, Execrate Andrew? Lalo, Eyes Wide Shut, Sean, The Missing Link, what's up? All right, cool. Got everyone. So the main reason why I wanted to do this live stream is because in the last live stream, Nachiketa went on and he asked me a question that I guess one of his callers asked him. I guess he was a stationary flat earther, if I'm not mistaken. I think his online name was Iron V1 or something like that.
XXVI or something.
Oh, there you go, XXVI. So Iron XXVI. So he basically asked him a question that I actually misunderstood because I guess the way Nach, well, when he asked me the question, I guess I misunderstood him. So I misunderstood the question about the skier, I guess, his deceleration rate being slower than 9.8 meters per second. I actually thought they were talking about like the skier going down a slope, and they were measuring the deceleration rate in the vertical, you know, um, axis, I guess you can say. So obviously being connected to the earth, I thought they were, obviously I thought, I misunderstood the question. I guess he was talking about the horizontal motion of a skier and with the air drag and so on. Why is the deceleration rate slower, right? So I figured instead of just answering it, I figured I react to the conversation. I guess I'll share the conversation. I give my thoughts as I go. That way, because last time he was on the chat and he didn't want to join the chat because it was right after the conversation with Nach. So I figured the next best thing will be just react to the conversation that he had with Nach, and then I can give my answers, I guess, or at least try to give the best answer to the questions that he has. And I guess we can go ahead and do that. And again, if anybody wants to join, the link is there. Don't be shy. You can click it, and yeah, for anybody that wants to share their thoughts. Again, if you think you can prove the globe Earth, the stationary flat Earth, whatever other model of the Earth that you believe in, concave, hollow Earth, whatever it is, if you want to, share your thoughts and your reasoning to why you believe or why you have those beliefs, please, please come on. So I'm gonna go ahead and share the video now. Give me 1 second. Okay. Okay, Iron XSV1 and not you get that. And yeah, let's just.
So what's the issue that is preventing you from being able to see our side of the story?
There's a few things, I guess. I think maybe it's just a bit of a shell game.
Okay.
Could I try and steelman your argument?
Go ahead.
Just through an example, if I've got an object and I release it, I guess the rising Earth claim is that that object slows down from the speed of the rising Earth and impacts the Earth still moving up towards it. Is that right?
I believe so. Yeah. I've heard to the.
Let me have this open so I can see if somebody joins. So I'm gonna have to share this screen a little bit different. So I'm gonna stop screen. Share screen. I'm gonna share a tab instead so I can still have this tab open. Okay, we'll share just a tab. Okay.
Extent that it starts to decelerate. It decelerates, and then Earth is still rising upwards. So yeah, so Earth is rising up and it's decelerating because it's losing momentum, right? So yeah.
Okay. So he moves away from, Dell moves away from Newtonian understanding where an object stays in motion unless acted on by another force. And he moves into the Aristotle fallacy of an object requires a force to stay in motion. Does that sound?
I don't know exactly what he was trying to say, but obviously he's talking about the first law of motion. Obviously, the first law of motion states that that an object at rest will remain at rest unless acted by an external force, and obviously that can be tested and replicated and repeated. It can be put through the scientific method, so that is utilized in everyday practical reality. The second part of that, where an object in motion will always stay in motion unless acted by an external force, that part of the definition that has never been proven. That's claiming that an object will stay in motion and constant motion without a force. That that literally defies physics. There is nobody has ever witnessed or yet alone tested or recreated that kind of motion, constant motion without a force. That's basically what they're claiming. You know, so again, a force is always going to resist the motion. It's always going to come. It's always going to decelerate. Always. If there's no force acting on matter, it's always going to decelerate. So again, inertia. It can only mean one. It can only mean either it resists motion or it doesn't. Inertia. So again, they're trying to double speak. They're trying to say, yeah, inertia will resist motion and changes in motion, but it also won't resist it if it's constant. But obviously that's in a vacuum. We don't live in a vacuum. We don't live in a frictionless environment. So that part of the definition that an object will always stay in motion is invalid. The fact that people bring it into a conversation about about the physical world, it just shows that they either don't comprehend what they're saying or they're completely being dishonest. So.
Sound
And
okay
we'll
to
continue
you?
with that thought.
Yeah, I'm just thinking if an object's released at a height, the only forces acting on that object will be the air rising with the rising Earth. So you're actually going to have a force moving or pushing that object up.
That is true. When an object is in free fall, it is going to experience an upwards push of the air as it decelerates. Because now there's going to be a difference of speed between the free falling object and the Earth. And the more the object decelerates, the more the difference in speed, the higher the difference in speed that the air pushing up is going to be, pushing up on the object. So yeah, the air is going to be pushing up on the free falling object more and more the more it decelerates, until eventually the air pushing up is not going to allow it to decelerate anymore. And that's when you reach terminal velocity, when it's the end of the deceleration of the free falling object. The air is able to push it up. The difference in speed is strong enough now to push up the object and not let it decelerate anymore. And that's what terminal velocity is. It's not the end of acceleration, it's the end of deceleration. So yeah, and it has to do with the air pushing up. So yes.
Well,
You can see
okay, it's like if you drop a feather in a bowling ball, obviously, outside of a vacuum, they're going to fall at different speeds, right?
yes, due to air resistance. Yep, the force of
Yeah,
air.
due to air. Yeah, but we agree that if they're in a vacuum, container, that they will fall at the same speed, correct?
Yeah, that's what they've showed us on the videos. So I don't have
I
any
mean,
proof otherwise.
yeah, I believe that is the truth of the matter. So, the air resistance does play a role on an object. Obviously, if it's like a lead ball and a bowling ball, it's not going to affect them at all. But there's going to be some amount of air resistance.
Again, the mainstream tries to say that air resistance is friction. So, but the fact is that the air resistance is actually the air pushing up. So that's what the air resistance is. But the mainstream, because obviously they have to go with the objects accelerating down in free fall, they have to say that the air resistance is friction. So that means the object is moving through the air and the air is providing friction. It's just like when a car is moving down the highway, there's air resistance, because the car is moving through the air, creating friction, So that's what the globe Earth claims. But the reality is, again, the air resistance that a feather experiences, more than the bowling ball, it's literally the air pushing up. That's the air resistance they're talking about. And again, they're just simply inverting the physics because they have to push the objects accelerate down, because they have to push a belief in the pulling force of gravity. Without that, again, the globe Earth falls apart.
Resistance that's there that is due to the upward vector. Is the way I understand it. Are you following me so far?
Yep, yep.
Okay.
Hey, and
No,
just
I
to just
understand
interject
that.
one thing.
Yeah. Go ahead.
So the wind direction also your height would pose a challenge at that point. If you're, you know, too far up, you know, you might have some crosswinds that hit at different directions. So, do these things get done in a vacuum chamber? Like, are these tests?
Well, in a vacuum chamber, I guess there would be no wind either, because wind is also dependent on, because like the air is moving sideways and swirling around such, right? So if you
Right.
remove that factor completely, there will be no wind in a vacuum
Right.
chamber,
That's
right?
yeah. Yes, sir. That's what I was hoping. Like, if there are tests done, I'd like to read those. That'd be cool to look more into it. Yeah, that way.
Okay. Iron, go ahead. Were you saying something?
Yeah. So basically, you've got an object with one force being applied to it. Now that object continues to move against the force, so it's actually moving through the air, and
Okay, so
basically,
what force is being applied?
Okay, now he's kind of like misrepresenting there. Again, I don't know if he's doing it on purpose or not, but or just he's having a misunderstanding. In other words, he's saying now the air is pushing up, and now there's another force, so the object's moving down, and the air is pushing up. I think that's what he's trying to say. Again, I'm not 100% sure, but it sounds like that's what he was saying. But that's not the case. Obviously, that object's not moving down. You know, it's still moving up, but it's decelerating. It's losing momentum, and the air pushing up is slowing down that deceleration because the air wants to keep pushing it up. But again, in the beginning, the difference in the speed between the free falling object and the air is not that great because they're still going pretty much the same speed. And then when you release it, it starts to slow down from that same speed, slower and slower and slower. So the difference in speed is increasing. The more that difference in speed increases, the more the air is able to push up on it and slow down the deceleration. Again, it's not that the object's being pulled down by another force. It's simply decelerating due to inertia. The resistance of motion. So again, the force has to be greater than the resistance to be able to cancel out the resistance. And again, until terminal velocity happens, the object's going to be decelerating. And the air is going to keep pushing it up. In other words.
To that object.
well,
Let's
the,
assert
the
that.
air attached to the rising Earth will be pushing the object up or applying a force upwards.
Yes.
I guess yes. In a way, there's a pressure gradient, and it's kind of like say the way I would imagine it. There's a kind of a different buoyancy with different density layers. Like if you have like a tube, and then you have like oil and water and like all the different materials in a tube, and then they naturally have their own buoyancy layer, but that buoyancy is due to the upward vector, and the air no different. The air will have a pressure gradient that is due to the upward vector. So is the air pushing up against there's kind of a resistance, I would say, against an object, but to say it's pushing up due to the upward vector, maybe that's correct. But I
Yeah,
understand
well,
what you're talking about. Yeah, go ahead.
sorry. You see it with your bowling ball and feather example. The
Yeah,
air is obviously pushing up against the feather, reducing its speed.
yeah, yeah. There's resistance to the air that is there,
Yeah, the air is pushing up. So
Yeah.
that is causing the feather to fall slower than the
So
bowling
this,
ball.
so this sort of gets to my sticking point, I guess.
Okay. Yeah, yeah. Go ahead.
If the air pushing up is the only force um, measurable or only force there, why does the object continue to decelerate? Is there something internal to the object?
because the difference in speed from the free falling object and the air pushing up is not great enough to stop the deceleration completely. So it does lose momentum and it does slow down the deceleration rate every second until it reaches terminal velocity. So eventually it does stop decelerating, the air pushing up. So what he's saying eventually does happen. but it doesn't happen right away. Again, the difference in speed between the free-falling object and the air pushing up has to increase enough to be able to push up on the object to stop the deceleration rate. Again, that will be terminal velocity. So yeah, the air can't push up and stop the deceleration rate, but the difference in speed between the free-falling object and the air pushing up has to be great enough to do that, which is for a skydiver in the belly flop position is 120 miles per hour difference between the air pushing up and the skydiver. How do we know that? Because skydiving simulators, indoor skydiving places that simulate skydiving, utilize fans that push air out at 120 miles per hour to be able to push up on a human in the belly flop position, so they can simulate skydiving, so they can be floating on air. And ironically, that's the speed they claim that a skydiver is traveling when they reach terminal velocity, when the air resistance becomes great to stop the acceleration. So can you see what's happening there? They're just inverting the physics from the air resistance and the skydiver moving 120 miles an hour to actually the air pushing up at 120 miles an hour, canceling out the deceleration rate. In other words, due to inertia. So again, they just inverted the physics.
That makes it decelerate?
Okay, so you're saying that the object should not be decelerating? Is that what I'm understanding? What you're
Yeah,
saying?
well, I can only see one force on it, and that's the air pushing it upwards. So
Okay.
in order for it to decelerate, it must have some internal mechanism or something associated with the object that.
Again, the resistance to motion, which is inertia. It doesn't have to be a force. It doesn't have to be something pushing up against it. It's literally the resistance to the motion, which in my opinion is some kind of static field. It could be the electric static field that people say they can measure. But again, at the end of the day, matter does resist motion. That's a fact. And whether you accept that matter does resist motion, whether acceleration or constant motion, it doesn't matter. Because if it resists acceleration, then it's going to resist constant as well. It's either it resists motion or it doesn't. That's what it comes down to. And matter does resist motion. Again, an object that can move forever without a force doesn't exist. That proves that matter does resist motion. Eventually comes to a stop. So yeah, let's go on to.
Makes it want to slow down.
Well, this is just my way of thinking, and maybe Dell. So I'm not obviously speaking for Dell, but this is just my limited understanding of what I imagine the situation to be. But objects themselves have an inherent density, and they are resisting motion. That's what allows them to have weight. So there's
So it's an inertia.
Is that the right way to put it? There's inertia with the object. Yes, there's inertia with the object because the Earth is moving upward. All the objects are being pushed upwards together, and then when the object is let go, there's no more that push, but it is losing. It's decelerating, so that inertia is becoming less and less, I guess, because the inertia means that there's a continuation of that motion. Correct? That's the way I understand inertia, right? There's like some object, like for example, if you're in
Yeah.
space and then you push an object, it continued to move without that force being applied to it because there's quote unquote inertia, right?
Yeah, inertia, resistance to force is my understanding of inertia. So if an object is in motion under Newtonian laws, it will continue to move unless there's a force applied to it.
Okay.
Again, inertia, the cause, whatever that is, again, it could be a static field, so it doesn't have to be a force like they try to claim. But again, to deny that matter resists motion all the time in this reality, whether constant or accelerating, you're basically a reality denier at that point.
So I guess I've got an object decelerating against
Okay.
a measurable force. That's my sticking point. Also,
Okay.
if we turn, so that means the object has something internal to it that makes it want to decelerate, whether it's energy being withdrawn from the object, or I'm not sure how else you could put it.
Well, I
Now,
mean,
if
like
we,
obviously, air is going to affect different objects differently, like we mentioned. So, like, yeah, it's going to really slow down a feather, but a bowling ball is going to behave in the same way as a lead cannonball or a steel.
Again, a feather is going to reach terminal velocity sooner than a skydiver because a feather requires less upwards push of the air. It doesn't require the 120-mile-an-hour wind, difference in speed that a skydiver will require to reach terminal velocity. A feather will probably require 5-mile-an-hour winds. So a feather reaches terminal velocity almost instantly because it only takes 5-mile-an-hour wind to push it. And in the first second, there's already a 22-mile-an-hour difference because that's what the 9.8 meters per second is. That measurable rate in free fall is a deceleration rate. So in the first second, 9.8 meters per second in miles per hour is 21.9 miles per hour in 1 second of loss. In other words, in the first second, there's a difference in speed of 21.9 miles per hour. So in other words, the air is pushing up at 21 miles an hour, at least in the first second. So that's why a feather instantly reaches terminal velocity because of its mass. It doesn't require that much force to push it up. So again, a skydiver is going to require more force, and obviously, the more dense the shape of the object, if it's able to cut through the air, be more aerodynamic, it's going to require more force. So again, just want to make that point.
Whatever. I mean, they're all going to have some resistance, but it's not going to be enough to really change anything regarding these objects, right?
yeah. So what you're saying is the force that the object has, the force that the object exhibits while slowing down is stronger than the force of the air pushing it up.
Yeah. Yes.
Again, I wouldn't call it a force. I would just say that the resistance due to inertia is greater than the air pushing up on it, again, in the first second. Depending on the object, obviously, if we're talking about a skydiver, it takes 12 seconds for the air to be strong enough to push up on the skydiver to stop the deceleration rate. But a feather, again, it reaches terminal velocity in a second. So again, it all depends on the density of the object. Again, because it has to do with inertia. If the inertia, the resistance due to inertia is greater than the force, then it's not going to be able to move it or push it. Until the force becomes greater than the resistance, then it is going to be able to push it.
So that has to be something internal to the object.
Yeah, which is what? Its density, its shape, the way in which
density
it is.
Well, again, the cause of the resistance is not internal, because matter, again, cannot move itself and matter cannot stop itself. So there is an aspect to this reality that makes matter resist motion. So that's what I would say. It's like a static field that's external to matter. And again, based on its density and its mass, then the more mass, the more density, the more resistance, in other words. But it's not doing that. It's not resisting itself. There's a cost to that. So.
Sorry.
I think
Go ahead.
might be able to help you out a little bit.
Okay, go ahead.
If you don't mind, though. So when he was saying inherent properties, I kind of get what it was going back to my point about height, because there's a gradient of charge as well as the higher you go. And if a feather, bone structures are hollow and let's say, lead is so dense but they both are going to be affected by the gradient of electricity, when it's falling or when the earth is coming up. I'll play devil's advocate for a minute. So in your scenario, the trees, everything are coming up. That's a much greater mass than what's would be inherently falling due to a release of whatever. But those objects are no longer affected by, let's just say 300 feet, give it not too high. And they both don't hit the ground at the same time. It's more likely that one's got more higher potential electricity in it than the other. Is that heading down the right path a little bit?
I'd be more willing to accept that the air force is a smaller ratio for the feather. I mean, the mass of the feather is not very much, so the air pushing it upwards would be reducing its fall by more than a heavy bowling ball.
Yeah, absolutely.
Yes, exactly. Again, like the feather reaches terminal velocity way quicker than a bowling ball when there's air resistance. Again, when the air is pushing up. So again, the air pushing up does have a factor to free falling objects. It does affect free falling objects, which is again is the literal cost for terminal velocity. It's the end of the deceleration because of the air pushing up. So, and again, it has in different masses are going to be affected differently. They're going to have different terminal velocities based on their mass.
So whether you drop something at 100 feet or at 1 foot, the acceleration is always 9.8 meters per second. So I don't think height has anything to do with it.
Well,
So no kind of charge, meshes with the what charge that the object's putting out. Because have you ever looked at Kirlian photography and how you
No.
can measure the electrical output of things? Look that up. It's Kirlian, Krilien, and it shows things that like foods that have been cooked. People that are sick, their hands glow more. That's beside the point. What I'm saying is you can measure visually the inherent electrical output and input and measure that quite accurately. So I'm just saying the higher you go in the air, the atmosphere, it also increases in charge. So somehow that's going to play a role.
Lalo, question: if we had no air and I threw a ball upward, shouldn't the ball constantly move up with the earth, never catching up to it because of the force of my throw upwards, plus upward moving earth? Again, you would have to believe that matter doesn't have resistance. That doesn't resist motion, and that's what I'm saying. In this reality, we don't live in a frictionless reality. Even when you remove the air, if you have something in a scale in a vacuum, you have a room and you suck the air out, right? Most of the air, because perfect vacuums don't exist. But let's say near zero, and you put a scale on an object and you push that object up, it's going to resist that motion, even though there's no air. So there is something that makes matter resist motion, at the end of the day. So again, like you said, even if you remove the air, same thing with a ball inside this room with no air. If you toss the ball up, because again, the scale is going to measure the resistance, and when you toss the ball up, there's also a resistance too. So that resistance, again, due to whatever the cause is, again, the background medium, whatever static field that's responsible for that, because of that resistance, it's gonna slow it down, and again, the Earth is gonna catch up to it again. So again, you have to believe that there is no background medium giving matter its resistance. You have to believe that matter doesn't resist motion. There's nothing. So matter just moves perpetually forever without a force because there's nothing to resist the motion once you put it into motion. So again, those claims defy physics. They cannot be demonstrated or recreated in any practical way. In other words.
Role. I don't know quite exactly how, but yeah.
So are you saying that objects released at a higher level fall faster than those at a lower level?
Well,
Like if
depending
I
on
got
its
a bowling
molecular,
ball.
depending on its makeup.
So if I had two
Not
identical
size, or
objects,
if it's if you had
just
two
say two
identical
bowling
objects.
balls, I release one at 1 foot and I release one at 100 feet. You're saying that they'll fall at different speeds?
No, no. If you're dropping it from an airplane or something, or let's just say a high diving board or something like that, doesn't have to be perfect. But what I'm saying is, the atmosphere will also play an effect. It has a role to play as well in weight, weight distribution, electrical output. Like, say you charged it up X amount and you put your finger to it, and your hair stood up, right?
Lalo, even without the air, again, there's going to be a resistance to motion, even in a vacuum, showing that it's not just the air creating resistance. You know, there's something else. There's a background medium. There's something else giving the matter its inertia properties of resisting motion. Because even in a vacuum, you can toss something up, it will resist the motion. You can put something in a scale and accelerate it up, it's going to resist that motion. Again, even without any air in the room, or with air being near zero, I guess.
Right, and then you did the same charge on something else, and your arm hair just stood up, right? You can put the same electrical charge into something, and it perform an output depending on the material, right? So that's beside the point. Is what I'm saying. If the higher you go, the equipotential increase is 100 volts per meter. And so you imagine 10 meters, it starts to increase really fast. So I don't know exactly how, like I'm saying, I can't do experiments myself, but I would think that would play a role in something falling or rising. Anyway, I'll leave it to y'all.
Okay, I just can't get something to fall faster at a kilometre up than I can at 1 metre up, or the acceleration. I don't think the electrical charge of an identical object, even if the charges are the same, I don't think that you can actually measure something falling faster at height than lower.
I don't know. Let's do an experiment. Let's find out.
Okay.
That'd be cool.
Okay. I just wanted to establish that an object that's been released and is decelerates at 9.8 meters per second against an upward force.
Again, it only decelerates at 9.8 meters per second in the first second, and in a vacuum as well. That's with no air resistance, by the way. For people, that make that claim, again, 9.8 meters per second decelerate or change of rate, whether you believe acceleration or deceleration, is with no air resistance. In other words, that with air resistance, not going to be 9.8 meters. Might be 9.6, 9.4. Who knows? Someone will have to conduct it again, and that would vary with different objects. A feather is going to reach terminal velocity way quicker, and is going to have a different deceleration rate than a bowling ball with air resistance. So just yeah.
So the air. Now, if we actually turn that horizontal and we get, say, an ice skater being pushed along by one of those ice rink levelers or resurfacers, if the ice skater pushes off that resurfacer, it's not...
Okay, he's going to get into this point about the ice skater horizontally and why an ice skater has a slower deceleration rate than a free-falling object when it's experiencing friction from the ice and air resistance. So he's saying that based on the 9.8 meters per second deceleration of objects plus the air resistance and friction, the deceleration rate should be faster than 9.8 meters per second. But what he's doing here is completely faulty reasoning, because different rates of velocity are going to have different rates of deceleration. What that means is that if a car is moving at 100 miles an hour, we'll use this for an example, the air resistance is going to be greater than if you're traveling at 50 miles an hour. In other words, there's going to be pushing back more the faster you're traveling through it. So same thing with resistance due to inertia. The more something is traveling, the more something is being pushed, the more resistance it's going to have. So in other words, it's the more pushback it's going to have, the faster it's moving. So in other words, it's going to have a faster deceleration rate the faster it's moving, because there's going to be more of a resistance, more of a pushback. So something that's moving slower is going to have less resistance, less of a pushback, is going to have a slower deceleration rate. So objects go from their highest deceleration rate in the first second all the way down. The deceleration rate slows all the way till it reaches zero, and it's no longer decelerating anymore. If something's moving horizontally, that means it came to a complete stop. If something is in free fall and it stopped decelerating, that means you reach terminal velocity. So again, the deceleration rate is the greatest in the first second, but it slows down every second after that until it reaches zero. So his point here is it's completely false, because as an ice skater, in my opinion, the 9.8 deceleration rate of free-falling objects obviously is from the motion of the Earth. So in my opinion, the Earth's motion is at least 1,000 miles an hour. That's just my opinion based on the deceleration rate of 21.9 miles per hour in the first second. So that shows the resistance that would be there due to inertia. Again, I'm not saying that it's 100%. That's just my opinion. It's at least 1,000 miles an hour. It could be faster, double, triple. It could be a little slower than that still. Again, I don't know the exact rate, but we do know is that in the first second, there is about around a 21 mile per hour difference in speed between a free-falling object and the Earth. And that rate increases as the object decelerates, but the rate decreases until it reaches zero again. So.
Not going to decelerate at 9.8 meters per second.
Well, you have two.
So again, where I was getting with that, I kind of lost my train of thought. So again, the free-falling object is the 9.8 meters per second is derived from a speed that's pretty fast. In other words, that means 1,000 miles. So for an ice skater that's traveling horizontally at less than 50 miles an hour and expect the same deceleration rate or greater than a free-falling object, that's completely illogical. You would have to claim that the Earth is moving at the same speed as the ice skater moving horizontally to be able to attribute that deceleration rate of the Earth to the ice skater, plus the air resistance and the friction. So again, you would have to attribute the 9.8 meters deceleration rate that comes from the Earth's speed to the ice skater moving horizontally. So again, you would have to say that they're moving at the same speed, that the Earth pushing up is moving at the same speed as the ice skater moving horizontally. And because of the friction of the ground and the air resistance, the deceleration rate should be even faster. But again, that's completely illogical. Something moving way faster, like the Earth, is going to have a way faster deceleration rate. So to expect something on Earth moving horizontally at less than 100 miles an hour, less than 50 miles an hour, and expect a faster deceleration rate doesn't make any sense whatsoever. So that's the whole basis of his argument. Okay. I guess Aaron is in the chat. This is incorrect. You cannot compare air friction that is reducing deceleration and air friction that is increasing deceleration. The forces are in opposite directions. Can I compare air friction and air friction that is increasing the deceleration? I don't know what you mean by that exactly. Do you get what he's trying to say? This is incorrect. You cannot compare air friction as reducing the deceleration. That's the air pushing up, I believe, as reducing the deceleration of an object. And air friction that is increasing. And air friction that's increasing deceleration. That's what you're doing in the horizontal vector. You're saying that you're doing that's increasing the deceleration. That's because you're moving through the air. In free fall, the air's pushing up against you. It's not the same thing. So the friction of the air in free fall is not the object moving through the air like an ice skater moves through the air horizontally. It's literally the air pushing up. So the air pushing up and an object in free fall is different from the friction that reduces the speed of an ice skater moving horizontally. So yeah.
I mean, Iron, you're more than welcome to come up.
Yeah, I mean, instead of me going over this conversation and kind of like, having to go like this, you could just join the chat and we can have a little chat. Maybe you can clear things up for me, or maybe clear things up for you as well, and maybe have a more productive conversation rather than in a chat. So again, the link's there. You can join whenever you want.
The long messaging,
so
it's inconvenient. So if you could call in, that'll be great.
Yeah, don't be shy.
two vectors to deal with because
okay.
so like the
Hey, how's it going?
Hey, can you hear me?
I can hear you. Here, let me stop
Okay.
sharing here.
Yeah,
All
I
right.
just sort of
So you
wanted.
were saying that. What were you saying about the air friction or the being different?
Yeah, so
Can you clear
the,
that up?
the air friction is in opposite directions for the ice skater and the free falling body. The free falling body will have air pressure or air friction pushing it up,
Yes.
therefore decreasing the deceleration.
Yes.
And the ice skater has the air friction pushing, trying to stop it, so it's increasing the deceleration.
Sure.
So that means you're comparing the air friction when they're doing the opposite in the way of forces.
I'm not comparing. You're comparing that. You're trying to compare the horizontal movement of an ice skater to the vertical vector. In other words, that's what you're doing.
Sorry, I just had someone walk in. What was that last question? Sorry.
Yeah, like what I'm saying is that that's what you're doing. You're trying to compare the horizontal friction of the air slowing down the skater to the upward vector, to the air pushing up.
Yeah,
That's what you're
yeah,
doing.
that's right. So that's why I'm trying to point out maybe an issue with your perspective of what's happening. So
Let me ask you this. Sure,
if
sure.
you've got a
Go,
free
go, go ahead.
falling, oh sorry, if you've got a free falling body and the air is pushing it up, that free falling body is going to decelerate slower because the only force that's on it is the one pushing it up.
It's going to decelerate its fastest rate per second in the first second, and that deceleration is going to increase as it decelerates more and more, but the rate decreases per second.
Okay,
But the
maybe do it
overall
this way.
deceleration is increasing because it doesn't reset in the second back to the constant again, and then decelerates and then resets again in the third second, and then that deceleration rate. It's adding to the previous second, and it's increasing every because you keep adding to it. But the rate in which it's decelerating per second is decreasing because the air is pushing it up. Yes.
Yep, that's fine. So I don't really want to go to a vacuum chamber, but I will. So if we reduce the amount of air friction in a vacuum chamber, we're not going to get a perfect vacuum. So you're saying that matter decelerates at 9.8 meters per second
In the
without that
first
air
second.
friction. Yep, without
Yes.
that air friction.
Sure. If that's what was
Um,
measured, then yeah, I'll accept that. Yes.
yeah. So that means that everything put aside, all forces put aside, that matter has, for want of a better term, an inbuilt want to decelerate at that rate.
It's not inbuilt because matter cannot move itself and it cannot stop itself. So it's an external cause, I would say. I wouldn't call it a force, but it's an external cause.
Yeah.
Definitely.
Okay. So do you know what that cause is?
I don't know.
No.
We
Okay.
can experience
So,
it, or we can experience the resistance of matter and then basically prove to ourselves that it's there. But what the cause is, I don't know.
yep. And would you say that deceleration in any direction would have that same deceleration rate?
No, different rates of velocity are going to have different deceleration rates because the greater the force, the greater the motion, the more resistance there's going to be, the more pushback. And the more pushback there is, the faster the deceleration is going to be in the beginning. And then the
So you're
slower it
saying,
gets, the less resistance, the less deceleration until it reaches zero.
so you've just said that the free falling object pushes back. That's a
The
force,
free
isn't
falling
it?
object, yeah, due to inertia, the force has to be greater than the resistance of the matter due to inertia, so it can stop its deceleration. So the more the object decelerates per second, the greater the difference in speed between the air pushing up and the free falling object is going to be. So the more the air is going to be able to stop it
Yeah, but
eventually till it reaches terminal
if
force.
we remove the air as much as possible, you're saying that object has a deceleration rate.
It has a deceleration rate, of course,
Yeah.
but I don't know
And
the exact deceleration.
what I'm asking
Rate.
is that deceleration rate the same in all directions? So if I throw a tennis ball,
No,
is
no, no,
that
no.
going
It
to
has a
decelerate
deceleration
at the
rate.
same rate?
It has a deceleration rate in the downwards vector in free fall only, that 9.8 meters per second, because it's from the upwards motion of the Earth. That's why that deceleration rate is 9.8 meters per second in the vacuum for all matter, because all matter is moving together with the Earth.
Yeah, but surely if something's going sideways, it has the same deceleration rate depending on speed. I think you said it was tied to speed.
Yeah, the again, if you're moving something horizontally at 100 miles an hour, that's way slower than the Earth, in my opinion. The Earth is not moving at 100 miles an hour. So to expect a faster deceleration rate of something slower than 100 miles an hour than something in free fall, it's completely illogical.
Okay, so there's a link between motion and deceleration rate, or speed and deceleration rate, no matter what the vector.
Sure.
Yeah. So I think I put an example on one of these chats. I can't remember which one it was, about someone on a train, maybe a train doing 200 miles per hour, whatever. There's no equivalence of a sideways deceleration on that train as there is up and down. So I think maybe you're overcomplicating it and calling this a deceleration rate when it might be something a little bit more simple and you don't have to invoke a rising Earth.
I think the globe Earth or stationary flat Earth invokes theories and mathematical concepts that cannot be demonstrated in reality. So they're overcomplicating it, in other words. The motion of the Earth is the simplest explanation that can be demonstrated and recreated, all the effects that we experience. So
okay, so if we remove the rising Earth, you say that rising Earth is like a natural law. Is that right?
Well, not necessarily, but it is required to experience all the effects that we are experiencing. There's no other way.
So that's built into creation. I don't know if you're a creationist.
It's part of the creation, sure. I'll say that, the motion of the Earth, the upwards motion.
Okay. So would it make more sense to actually move that deceleration rate from a rising Earth just into the object itself, or matter, and say that all matter falls to the Earth?
Are you claiming that all matter accelerates down to the Earth? Is that what you mean by fall?
So matter has a normal state of being grounded or being on the ground.
Well, again, what's the cause of that? That's what's that question.
I'm saying
Why?
that's just built into creation, like your rising Earth is built into creation. So instead of claiming a rising Earth, why can't you just move that claim onto the matter and say all matter wants to go to the ground?
You know what else is built into creation that can be demonstrated and recreated? Accelerometers. Do you deny that accelerometers are part of our reality and detect acceleration?
No, I agree with your free-falling bodies have no force.
Sure. So do you believe objects can accelerate without a force? And you do believe that, right?
I believe that an object in free fall wants to go to the ground, or all objects want to go to the ground.
So no, I asked you. So you believe objects can accelerate without a force? You believe that, right? That's a yes or no.
Yes, the same way that
Yes.
you believe that objects can decelerate without a force.
Okay, let me ask you this: if a force has never been, then I'll go to you right now, Roller. Give me 1 second. If a force has never been demonstrated or recreated that can accelerate without any displacement, or in other words, without any effects of acceleration, why would you believe that such force exists?
Technically, it's the same force that you use to decelerate an object.
No, I'm asking you, why do you believe that kind of acceleration without any pressure or effects of acceleration? Why do you believe that kind of force exists?
Because I believe that all matter wants to go to the ground.
But why do you believe that?
Or its natural state is at ground level. Why do I believe that?
What is your justification for that?
Yeah, do you have anything practical that makes you believe that?
The exact same experiments that you show.
So just releasing an object into free fall is what you're saying is what proves to you that objects accelerate down?
So all I'm doing is I'm moving. It's not an acceleration, it's a lack of force. So if there's no force on an object, it will find its way to the Earth.
So what's your definition of acceleration, if I may ask?
A change in velocity.
Increasing by the second, correct?
Yes.
So does the change of velocity increase by the second of a free-falling object?
It's measured at 9.8 meters per second, and then I guess if you get air resistance, that'll reduce.
The question was, does a free-falling object increase its velocity per second?
Yes, it does.
So does the object accelerate down in free fall? By
Yes.
definition? Yes, correct.
Yeah.
So if every practical example in reality shows displacement or reaction to force or acceleration, why does that vanish in free fall, but why do you believe that again? It doesn't make any sense to me.
Because I'm replacing your rising Earth with
I understand
the
you're doing that,
deceleration.
but why? What convinced you that objects do accelerate down? I guess is my point, because matter shows that there is no acceleration down. So I'm kind of like lost.
The reason I looked at the rising Earth and I found this inconsistency with horizontal movement and vertical movement. If you move the onus of deceleration or acceleration to the Earth onto the object or to actual matter, then that inconsistency goes away, and you're not left with what is way out there idea that the Earth is rising constantly forever and ever and ever. You don't need that.
Right.
You can have a stationary Earth, and the matter is the thing doing the moving.
Okay, give me 1 second. Let me just welcome Rollerball. Hey, Rollerball, can you hear me?
I can, William. How you doing?
Oh my God.
Come on, man.
All right, let's get rid of that. So I'm sorry. Can you? What was your point there at the end?
So I was saying that instead of claiming a rising Earth, which is a pretty big claim, that is, I mean, we can't prove that the Earth is rising. You can do experiments and stuff that show certain reactions to matter. But what I'm saying is if you move that rising Earth component onto the matter, then there is a consistency between horizontal movement and vertical movement, which is a problem for the rising Earth.
Are you saying that when you move at a horizontal rate, for example, that you get no displacement? Is that where you're going?
If you move at a horizontal rate, the thing that's slowing it down is the air friction.
That's not the only thing slowing it down. That's the thing.
In a horizontal way, it is.
No, it's not. It's still resisting motion due to inertia. Inertia doesn't vanish just because you start moving an object in the horizontal vector. Inertia is always present.
Yeah. Can you give me your definition of inertia? Because there's two components to inertia.
Yeah. So the simple definition to inertia is simply that inertia resists motion. So inertia basically means it wants to make matter remain motionless. It wants to make matter static.
Is that something that you've just thought of, or is that a definition that you've actually pulled from somewhere?
That's actually derived from practical physics. When you increase the motion, you increase the resistance. And you can do that in a vacuum as well.
So you're not using the classical definition of inertia from Newtonian laws of motion?
No, I would go with
So maybe you should use a different word to inertia then.
I mean, sure. I mean, these are just words at the end of the day. It's what can be practically shown at the end of the day. And what can be practically shown is that matter does resist motion, whether constant or accelerating. There is something that causes that resistance.
Okay, so I guess you've cleared up a few things. So you're saying that motion in a horizontal direction is reduced via the air friction, and also inertia, which is a non-force force that stops matter.
Sure, it's just a cause that stops matter. Sure.
Okay, so what I've heard Del say a lot of times is that stationary earthers or globe earthers or whatever have to believe in a non-force force that's acting on matter to get their outcome of their understanding of what's happening in nature. But what we've displayed here is you've also got that non-force force that is acting on matter. So it seems to me like there's just a shell game being played here.
No, because what can be practically demonstrated is that matter will always react to acceleration. That's a fact. And you deny that fact because you have a bias to believe objects accelerate down. And I ask you, where do you get that belief from? Because it doesn't come from practical physics. It's coming from your imagination. The belief that objects accelerate down without any displacement, that is a complete contradiction of our physical world. And I'll ask you again, where do you get that belief that objects can accelerate in that manner?
Because if I drop a pen, it falls to the ground.
That's special pleading. You need something else that can show you that is possible, because that's what's at question. That's what needs to be proven. You cannot use the phenomenon itself, to prove your position. You're a stationary flat earther, right? If I'm not mistaken, or you're a globe earther?
Yeah. No, stationary
Okay.
flat.
Yeah, that's no different than Neil deGrasse Tyson dropping the mic to prove gravity. Pulling force.
I guess the motion of the Earth to the rising Earth, wouldn't that be a special pleading as well?
No, because you can decelerate without displacement. That can be recreated. That exists.
So my deceleration without a force is exactly the same as yours, except I'm not having the Earth rising, I'm having the matter fall.
Here's the thing, I can recreate deceleration without displacement in a different vector. You cannot recreate acceleration without displacement in a different vector. And that's how simple it is.
Yeah, I just don't think you understand that my argument is exactly the same as yours. I'm just changing one component. Whereas you've got the rising Earth, I've got the falling matter. So basically they're the same thing without the rising Earth.
Iron, are you otherwise known as PK?
No.
No, you didn't just mute yourself with the rollerball and
With what?
try to throw everyone off.
I'm sorry. What was that?
So you're not PK, is what you're saying?
No.
Right. Okay.
Okay, Michelle, can you hear me?
Yeah, this is PK. You guys are cowards and lying to your audience. Why are you so scared to talk to me? And hi, Iron. I don't know who you are, Iron, but you're definitely not me.
I'd like to hear them both talk at the same time.
Right. Yeah, I already spoke to PK a couple of times, and yeah.
Okay.
All right, so
I'll jump off.
The deceleration without displacement can be recreated, so that is a part of our reality. So your belief cannot be recreated. It actually defies physics.
Okay. Yep. All right then. Well, thanks for the chat. I sort of came in, tried to give it my all.
No worries.
Yeah, I'll hang around in the comments section. Thanks for that.
Yeah. All right, no worries. Take care.
Yeah, there was too many similarities for me. It would have been nice to hear them talk at the same time.
Oh, yeah, that was thinking.
I mean, again, it just sounded like he was trying to change his voice, but I mean, could be wrong. Although I'm not the only one that kind of noticed that.
Right. I mean, should we even finish the video at this point, right? What do you think?
I mean, you just had a conversation directly with him.
Yeah, I think it's pointless to I guess to finish reacting to that. So I guess I'll read some of the comments, see if anybody has anything important or something relevant, I guess. I don't want to go too far back, but how far do you think we're here more? Yeah, I think that's good.
When the conversation started was probably around.
Again, anybody else wants to join, the link is there, just click it and yeah, you can share your thoughts.
This is where we go.
Okay.
I guess I just heard similarities.
Okay.
I just sound like PK, but kind of deeper.
Right, like a voice changer, maybe.
Yeah.
Right? I guess.
Oh, well, not necessarily a voice changer, because I
Okay.
still kind of heard the similarity.
Oh, yeah. I mean, you can't trust anyone nowadays, especially if they're faceless, you know. But yeah. Oh. Hello, Amanda Cat, can you hear us?
I can. Why are you guys so scared to talk to me?
Oh,
What?
my God. You guys
Honestly,
are
why?
kidding me. Wow.
Amanda.
I was like,
he's betraying you now. Can't call him out.
Oh my God, he's desperate.
he read his name 3 times and then appeared.
Should we see what he has to say?
I mean, no one's scared to talk to him. It's more of like an annoyance. There's
All the way down.
mhm.
Okay. It seems like we're just waiting for someone to explain what's up with accelerometer showing a decrease in speed when it's dropped. Exactly, yeah. I mean, I guess I'll add him for a bit to see what he wants. All right, PK.
Come on, guys. This is getting a bit ridiculous, isn't it? I'm not a troll.
What, you
I just
calling
wanna
in about the same thing?
What do you
kinda.
have?
Okay, listen. I'll keep this one nice and short, but clear, right? Can you hold up that jar you've got there again, which you use for your demos?
Talking about this one?
Yep. So you say that when you accelerate the jar, the ball inside moves in the direction of acceleration, right? Just show everyone again.
Yeah.
That's not what
sure.
he says. It's what we can demonstrate.
Sure.
Okay, sorry. It's not what he says. It's what we can see, plain and clear.
Sure.
Okay. Now, why is the ball pushed upwards? Why does the ball want to go to the top of the jar right now?
Because it's being pushed up by the Earth, which is being it's transferring that force through the container and the water. And
Exactly.
Push.
Now, what you failed to mention in all of your streams, William, is you say that the Earth is moving upwards at a constant velocity, but clearly that ball only moves when it's accelerated, not when it's moved at a constant. So logically, you have to admit that your theory says that the Earth is accelerating upwards, not moving upwards at a constant speed.
I have to move it. I have to accelerate it because I have to overcome that constant. So that's
William,
the reason
that
why I
doesn't
have
make
to
any sense.
accelerate it.
What you just said doesn't make any sense. Hold it up so everyone can see again. You're saying that the ball is upwards when it moves in the direction of acceleration. Now the ball in that jar right now is upwards, right? It's trying to go up. So doesn't that mean the Earth is accelerating upwards?
No. Because if it was accelerating up, the rate of the ping pong ball or the buoyant object will increase as it's moving through the medium. That does not happen.
William, that explanation doesn't make any sense. And I'm
If
wondering,
it was accelerating up, the ping pong ball will accelerate up through the medium as well, and that does not happen.
William, you use the word gradient a lot, right? The ball moves because a gradient is created inside the jar when it gets pushed around, right? When it's accelerated. That gradient exists in that jar right now, causing the ball to be wanting to be pushed upwards, true?
Yeah, and that gradient vanishes in free fall.
Exactly. Now, that gradient only appears when someone accelerates the jar side to side. So doesn't that mean the jar is accelerating upwards right now?
You're saying the same thing.
Yeah, but you haven't explained why it's a constant speed and not an acceleration that's creating that buoyancy.
It's a constant speed because our weight doesn't increase, because the buoyant object doesn't increase its speed through the medium. Everything shows that it's a constant.
I'd like to know if anyone in the chat understands that answer right now, because I sure don't. I don't know what that means, William.
Well, that's a
Sounds
personal
like a you
problem.
problem.
That sounds like a personal problem. So I don't know how to
Okay,
help
I mean,
anything.
it seems your entire model is based on a jar being accelerated pushed from left to right, which shows the ball's moving in the direction of acceleration, a low density ball. But then when I point out that the ball is being, buoyant upwards, that has to be due to accelerated motion, doesn't it? Not constant motion, not constant speed.
No, acceleration will cause the ball to accelerate through the medium, and that does not happen. Let me ask you this:
Sure.
Why do you believe objects accelerate down without displacement?
Well, I told you I'm a glober, right? I think that gravity
you still believe the
is
same
a
thing.
phenomenon. I think gravity is a phenomenon, and masses attract each other. And a large mass like the Earth attracts other masses and pulls them down.
Why do you believe all that?
Because that's what I see when I let something go. It falls down.
Okay, but you'll get the same effect. Wait. You'll get the same effect if it's the Earth moving up and the object decelerates down. What would you expect to see?
You're absolutely right. We would expect to see the same thing.
My question to you again: why do you believe that mass attracts mass and object accelerate down without displacement?
Okay, because there's a ton of other evidence that comes along with this model of globe Earth and heliocentricity and gravitational forces attracting.
Give me your best one.
Yeah,
Give me your
can
best
you
one.
provide
Give me
one
the
since
best evidence, because there's so
many?
much. Give me the best one right now.
Okay, I can give you a couple. Right, here's a simple one.
Give me the best one.
Okay, the values of acceleration and things like trajectories of objects thrown through space can be perfectly calculated with our mathematical understanding of the values and properties of those that matter.
Are you talking about sending satellites to outer space or
I'm
objects
talking
to
about
outer space?
things like shooting cannonballs or shooting a bow and arrow in the backyard. We can calculate the exact trajectory when we use the values that we understand of gravity on the surface of the Earth.
That would be the exact same thing, but if the objects were decelerating due to inertia instead of gravity pulling them down, right?
Okay, but
so
William,
the question again: how do you know it's one or the other?
Because the science that globers use works, whereas yours doesn't. I'll give you an example.
What science are you talking about?
Okay, I'll tell you the science. We know the mass of the Earth. We know the mass of the sun. With those two values, we can calculate the force between those two bodies.
How do you know the mass of the Earth? If I may ask before we go on with that.
There are ways to work that out. When you know the radius of a body and you know the average density of that body, you can work out its mass. It's very simple. But you, on the other hand, you're assuming, like, where did you come up with 1,000 miles an hour for the Earth going up?
I'm not saying that's what it's moving. I'm saying that's at least what it's moving at.
And
it's coming from the deceleration rate of 21.9 miles an hour in the first second.
How did you link those two numbers? How do you link those two numbers?
No, I'm saying that because of that deceleration rate in the first second is so great, then the speed that the Earth is moving must be great as well. It could be less than 1,000 miles an hour.
How did you come up with 1,000 though? You're just guessing, aren't you?
1,000 is just a general number that I like to use. It's an easy number to visualize, because it could be. It's not going to be a whole number. It's not going to be 900 miles exactly. It's going to be. It's not going to be a whole number.
Right. My point is, you're completely guessing, though, aren't you? It's a complete guess.
Yeah.
Right?
Sure. The upward speed of the Earth, nobody knows. That's irrelevant, though.
Or I could guess 100 miles an hour.
That's irrelevant, though. We don't need to know the exact speed of the Earth to know that it's moving.
But it kind of is relevant, though, because no, it's not. How can you make these experiments, you make these observations? Why can't you deduce and calculate any values from those observations and experiments?
What do you mean? All the values that the globe Earth uses with gravity are the same values that can be used with an upwards rising Earth and a decelerating object, 9.8 meters per second.
Yeah, but 9.8, we can come up with that number based on values that we measure. Your 1,000 miles an hour, you just came up with out of thin air.
Where did the 1,000 miles per hour spin of the Earth come from?
You say that the Earth is moving up at 1,000 miles an hour.
No, I don't say that it's moving. I'm saying it's moving up. I'm saying that 1,000 miles an hour is at least the speed that it's moving. It could be moving faster.
Okay, but my point is,
I don't know the exact speed.
Okay. I want to finish on one more point. Inertia. Your model of inertia is different to mine.
Since we're talking about this, let me ask you real quick before you go to your next point. why do you believe the Earth spins at 1,000 miles an hour or over 1,000 miles an hour?
Because we have day and night. We have day and night, and the Earth,
Okay.
the sun rises, the sun sets, and we can predict and calculate. And I can tell you exactly what time the sun will rise and the sun will set in your location in a year. You can't do that using your flat Earth model.
So you're basing that belief of 1,000 mile an hour spin based on an observation of the sun,
and our understanding of the size of the Earth. Yes.
which is an assumption.
Well, it works.
Based on a belief that objects accelerate down at the end of the day, because it has never been proven. So the size of the Earth, all of that being a ball, it's all
how is it?
speculation.
Okay, how is it we can predict the exact time the sun will rise in California, where you are right now, 3 months from now? How do I know? How are we able to work that out? How are scientists able to know that?
Because we probably live in a geocentric environment, which is a cycle. We live in it's a cycle. The stars and the lights in the sky is a cycle.
But there's no flat Earth or level Earth mathematics that's able to do that. Only globe Earth mathematics can predict sunrise and sunset times in any location on Earth.
I mean, these predictions doesn't prove the dimensions of the Earth.
It's pretty good evidence, William. You have to agree. It's pretty good evidence. If we can predict the exact time of sunsets and sunrises, that's pretty good evidence that we know, the nature of the solar system and the Earth, right? You got to admit. Something as simple as
the lights in the sky don't prove anything
about the ground, and you have to make so many assumptions for that to fit your model.
But it works, William. It works.
Without a bunch of assumptions. Yeah, sure.
Not assumptions.
I can come up with an explanation to fit something perfectly. It doesn't make it true.
Yeah,
okay, William. While a few streams back, we had a discussion about inertia, right? Your claim is an Aristotelian model of inertia. You say that masses need forces in order to keep moving, right? Whereas I say masses will keep moving unless a force acts on them, right?
Sure, that has never been shown, but yeah.
Okay. If what you say is true, can you explain why, if we are flying in a jet plane at 600 miles an hour, 800 miles an hour, and I drop something in the aircraft, like if I drop a pin, will the pin fall straight down or will it curve back towards me?
I don't know. You have to be flying at 800 miles an hour in a jet and do that.
You honestly don't, like, according to your model.
I don't know what would happen.
According to your model, as the object falls in the plane, it goes down because it's slowing down because the Earth's rising. But shouldn't it also slow towards the back of the plane because the plane is moving forward and the needle is moving forward?
Again, it depends to the speed of the Earth. If it's pretty, it depends. I don't know, 800 miles an hour.
That's your model. That's what your idea of inertia predicts.
You have to do this test first. You're talking about speculation right now.
It's a very simple
Until you can do that test and observe what happens, and then.
Okay, William, have you ever been in a plane? William, have you been in a plane and gone overseas?
Sure, they fly around 500 miles an hour allegedly. Sure.
Okay,
that means the Earth is moving way faster.
Have you been in a plane though?
Sure. Yeah.
Okay, and like if you drop something while you're in the plane, do we see it curve or do we see it go straight down in the plane?
It goes straight down due to the greater resistance of the upward vector.
What does that mean, William? That's word salad. Greater resistance of the upward vector. Last time you got out of
the resistance due to inertia because of the upward vector.
Hang on, so William. The last time we had this argument, I created a model of a marble on a sheet of glass, and you got out of it by saying the marble is connected to the glass, which is connected to the Earth.
Yeah.
This
you
time
didn't remove the upward vector.
Okay, this time it's not connected to anything. It's falling, right? So it's accelerating down because your idea is that it's slowing down because it's moving up. But why isn't it also slowing backwards towards the back of the plane? It'll go straight down. Everyone listening to us,
but it's experiencing a greater resistance down because it's being pushed up at a greater rate. And if an airplane is flying level, it's still moving up with the Earth. If an airplane is flying level, listen, if an airplane is flying level, it's still moving up at the same rate of the Earth.
We're not talking about vertical motion. We're talking about horizontal motion, William. The plane is moving horizontally.
Even if it's moving horizontally, flying level, are you saying that when you fly horizontally level on an airplane, that you eliminate the upwards push, the
Well,
upwards
while,
motion?
while it's falling, the upwards push isn't going to affect horizontal motion, is it?
Yeah, it's going to affect all the matter that's inside that's being pushed with the
the,
airplane.
the
Yeah.
object is falling in the plane. It's not touching any physical surfaces.
Yeah, but it's still being pushed up by the airplane, and whoever's holding the object inside the airplane
No,
is being
yeah,
pushed up.
I'm not holding the object, William. I dropped the object. The object is falling within the aircraft.
Sure.
Nothing's touching it anymore. Shouldn't
yeah,
it
but
move backwards as well?
If it's experiencing a greater resistance and going down because it's being pushed up harder, then no.
Can you not appreciate you're just making stuff up on the spot? None of what you just said makes any sense. And if it does, I'd
You're
like
not
anyone
actually-
listening. I'd like
You're not
anyone
actually
listening
listening.
right now to come on and explain what you just said, because seriously, it's just not making any sense.
Did you eliminate the upwards vector is what I'm saying when you're flying horizontally to expect it to go back?
What upwards vector? What are you talking about?
The airplane that's maintaining its level flight relative to the Earth, if the Earth is moving up and the airplane is maintaining that same distance from the Earth, that means the airplane is flying at the same speed upwards than like the Earth. It's moving at the same rate up to maintain that gap.
Yeah. That's why the object looks like it falls down. I get that. But why doesn't it fall back towards the back of the plane if the plane is moving forwards? Because inertia would want that mass to slow down and stop. That's what your idea is, right? The falling object wants to stop moving, right? So if it's moving forward at 500 miles an hour in a plane, shouldn't it want to slow down as it's falling as well and move towards the back of the plane? In other words, shouldn't the trajectory be curved backwards, not a straight line?
Put it this way. It's experiencing a greater force up, even though it's still flying. Because again, it's in my opinion, it's flying. The Earth is moving at least 1,000 miles. It could be way faster than that still. My point is, because it's traveling faster in the upwards vector to maintain that level flight, even if you're moving at horizontally at 500 miles an hour, it's going to have more resistance down because it's experiencing a greater force, a greater speed up.
But
so that's the simple answer. And it might not fall directly straight. It might fall maybe a little bit more back.
Oh, come on, William. Come on.
I don't know.
So your theory says it should curve, right? Your theory says it should curve back.
An airplane is not that tall. How tall is an airplane? Like 10 feet? It only has 10 feet.
Okay, but
it's not going to be that.
500 miles an hour. Listen, 500 miles an hour is half of 1,000 miles an hour. So wouldn't we expect to see half the acceleration?
That 1,000 miles an hour, it could be way more, first of all. And second, I don't know what this has anything to do with proving downward acceleration.
This has to do with inertia, because this is one of your key principles that your theory relies on, inertia.
So do you deny that matter resists motion then? Do you believe we live in a frictionless environment that matter just doesn't resist motion? Is that where you're going?
William, I think that in our everyday experience, frictional forces are everywhere and things tend to slow down due to friction, not due to their natural tendency to want to slow down.
So you're saying that if there's no air, there's no friction. That's what you're saying. There's no resistance.
If there's nothing touching the mass, nothing will slow it down. Even if as long as there's no other forces acting, like non-contact forces, like magnetic or electric or gravitational, it will keep going.
In a vacuum, if you accelerate something up, there's nothing in front of it to resist that motion. So why would it resist motion in a vacuum?
Because it's on Earth and gravity is pulling on it. But if you did that experiment in deep space with no masses around it, no planets nearby, there would be no forces on it. It would just keep moving.
So how did you prove gravity?
Are we back to this again, William? You know I can't do an experiment in a laboratory to reproduce the same amount of gravity as there is on Earth. That's impossible, right? You know that.
So it's just a belief then, is what you're saying.
So you appeal to higher authority.
Well, your ideas are coming from a whole bunch of assumptions that you're not able to prove as well.
It's coming from demonstrable reality.
Okay, here's another question for you then regarding your jar experiment. You say that when you let go of something, it's slowing down, right? Because the Earth is moving up and it wants to slow down. So isn't it, in fact, changing its velocity?
Yes.
So isn't that called acceleration or deceleration?
You can call it acceleration, sure.
So why isn't the jar showing that?
It's just deceleration that's happening.
Right.
You call it acceleration, but it's a deceleration.
Why isn't that showing, the jar and the balls showing that if it's an actual acceleration? Just like
No, it's an actual deceleration. It's a
A
loss
change
of
of
momentum.
velocity could be deceleration or acceleration.
That's right. That's
You're
what I'm
just
saying. So
you're
it doesn't
claiming
matter
it's acceleration.
right. It doesn't matter whether it's slowing down or speeding up. You
No,
should
it doesn't
still
matter.
see
Yeah.
like
Speeding up will show the displacement, and slowing down wouldn't. So
Are you
it doesn't show the
you
displacement.
don't think slowing down shows a displacement
If
as
you
well?
don't, if without a force, it wouldn't show displacement.
Well,
If
there
you
has
slow
to be
down
a
without a
to slow it
force,
down. William,
no,
it has
it
to.
hasn't.
William, when you pick up that jar and you push it across, how do you bring it to a stop? You apply an opposing force in the opposite direction, right? To bring it to a stop. That's a deceleration. And
Yeah,
you'll
you
notice
can apply it.
if you watch your
You can
videos,
apply force, or you can just stop applying that force.
if you
applying
watch
that
your
force.
videos, you'll notice the ball moves to the opposite end of the jar when it slows down. Try it now. Do it in front of you. Watch it.
Yes, I know. When you apply a force and slow it down faster than the deceleration rate due to inertia, then you're going to get a displacement.
Right.
If
So
you decelerates faster than the displacement than the resistance due to inertia.
Well, you said that there's some sort of static medium that is acting as a resistance force on all masses, which causes them to slow down. That's what inertia. That's part of your model of inertia. You said that earlier in the stream.
Yeah, it's a resistance.
It's a static field of some sort that is applying an opposing force to slow things down. Right? That's your explanation of it, isn't
I
it?
wouldn't call it a force, but sure, it's a cause to slow matter.
But how? How does it slow matter if it doesn't involve a force?
It's a static field. So it's,
and what is the static field?
It makes matter want to be static. I don't know how it works. I don't know the mechanism of it, but I'm not the creator.
Doesn't
You
it
can
have to
experience
be
it,
a
though.
force? William, doesn't it have to be a force?
You're asking me how life works, how my consciousness works. Like, I don't know that. You can experience it, though.
William, this is a cop out. This is a cop out now. This is a cop out. You know that to slow something down, you need to apply a force to it, right? And
No,
your
you need a
static
cause.
field-
I agree. You need an external cause.
And
there
don't
is a
tell me
cause.
to fuck off with my vacuum, Earthship Bear. That's being really rude. I'm not being rude. I'm just trying to have a normal conversation. Some of your listeners are being really rude here, William. I'm not being rude, right? And I'm not a troll.
We don't control the listeners. We can only.
Well, someone told me to fuck off, so I don't want to.
That seems like a you problem again.
Okay, fine.
I mean, if there's anything.
Fuck off. How about that? All right, Earthbear can fuck off. So, William, your static field needs to apply an opposing force. True.
Again, I wouldn't call it a force because I don't claim that the static field is flowing. Again, I don't know how it works exactly.
Mass is moving through the static field. It's not obviously it's static. It's not flowing, right?
Sure.
That's what the word static means.
But force will be something that's in motion that causes something else to have motion. This will be the opposite of that. So I wouldn't necessarily call it a force.
You just proved my point. You just said exactly what I said. The force is slowing it down. So that's causing it to decelerate. True. But the jar doesn't show that.
Fresh. Sorry. Let me welcome Fresh. Can you hear me?
Yeah, brother. How you guys doing?
Good, Fresh.
How are you?
Another day in paradise. You guys are way more sophisticated than me, to be honest. I've been listening. Didn't do that much schooling in my lifetime, but I'm just here to learn.
Well, we're happy to have you, Fresh.
Yeah, it's probably best you didn't do much schooling.
All right. Well, PK, any points that you want to make before?
William, I'm going to leave it there. But I would really like you to look back at this stream and come up with some coherent explanations for the 2 or 3 questions that I had, right? Because and really listen to the answers that you provided, because you'll realize they don't make any sense, William. They really don't. And I really would like you to come up with something that does. Okay, so I'll leave it with that. Good night, everyone. Enjoy the rest of your day.
Yeah, thanks for the homework.
That was quite the exit. That's a performance.
Yeah, he has to. He's like those policemen that have to tell you, that have to give you a directive. It's just
Do you want my camera on or not? I look terrible, but I'll turn it on.
Whatever you're comfortable with.
Yeah, I look bad. I'll turn it on. It'll make your channel look bad. I look awful. I got a face tattoo and everything.
No, it's good, man. It's always good to see people, show face. It's always better to see the actual human expression than just
because when you started, you were showing off these water bottles, and I'm like, I must be on the wrong panel. I was like, I don't even know what's going on right now.
So let me ask you, where are you coming from, if I may ask?
I was born in Missouri, St. Louis. I live out in Arizona now. Um,
Okay.
I don't think
So,
I'm qualified for this panel. Y'all are way too dang intelligent. I gotta be honest with you.
oh, let me. Well, I mean, understanding our reality at the fundamental level is very easy. For example, so I would ask you, are you a flat earther? Do you believe the Earth is flat or globe? Where are you at in your beliefs?
I'd probably say round, but that's not based on any studying. It's just what I was told my whole life, so I never questioned that. And then
Right.
I don't know, on Joe Rogan like 4 years ago, out of nowhere, flat Earth became this big phenomena. But
Right.
either way, it doesn't affect my life 1 cent. So if it's flat, then it's flat. But
Hmm. So, if I
if
mean, if it doesn't really matter to you whether the Earth is a globe or flat, I mean, not to be disrespectful or anything, but like, how did you find my channel? Like, how did?
I just typed open panel live streams. That's what we do at night. We just click buttons, jump on.
Oh,
Is this a
interesting.
flat Earth panel? I didn't know that. My
Mm,
bad.
No, it's not. It's not a flat Earth panel. Again, flat Earth is a false dichotomy with the globe Earth, but it is a anti-globe Earth channel. I guess you could say everybody here doesn't believe the globe Earth.
Okay, well, teach me something. All right, so we're not flat Earth, not global.
It's
What are we?
we're
Or
we're
what? Or
level.
kind of where you coming from, sir?
So level. You've heard of level, right? Like one of us, for example. Have you seen one of these? A
Um,
skirt level, right?
I'll just say yes for the sake. Oh, I know what a level is. I thought you meant the
Yeah.
Earth
There you
being
go.
leveled.
No,
Yeah,
you know
yeah, I
what
know
this
what
is,
that
right?
is.
Level. Yeah. What would be your definition of level?
No, I thought you were saying the Earth was leveled, but not flat, but not global.
No, yeah,
Forget
that's
it.
where I'm
I
going.
give
But
up. I'm so
what would be your
sorry.
definition of level, if I may ask?
Uh,
What's your
flat.
Could we say horizontal, perpendicular to the vertical?
Yeah, horizontal. Sure.
Right? So again, the Earth is level because it has orientation, right? You know what orientation is, right? When the air bubble is completely centered, for example, this is perfectly horizontal, right? So we're able to level this level here on Earth because it's experiencing a vertical force. You will believe it's gravity, a pulling force of gravity, right?
Okay. No, I'm listening,
The,
brother. I'm listening.
yeah, but the fact is, gravity as a pulling force that levels this instrument, for example, doesn't exist. How do we know that? Because if we were in free fall, like in a free falling airplane, for example, and you try to level this tool inside a free falling airplane, you wouldn't be able to level this because it would not be experiencing a vertical force in free fall. So I don't know if you knew gravity is just a theory because it has never been proven that objects accelerate down towards the Earth because there is no vertical force in free fall. So the vertical force we experience here on Earth, it's an upwards force. It's a push of the Earth. So the Earth doesn't pull you towards the ground. It's the Earth literally pushing up against you. So that debunks the globe Earth because again, if you believe you live on a ball and it's the ground pushing up and it's not pulling you down towards it and it's literally moving up, then that would mean that the Earth will have to be expanding on a globe Earth. It will have to be moving up in every direction simultaneously, and that would mean that the globe Earth would just explode. So the fact that gravity is not a pulling force, but it's a pushing force of the Earth debunks the whole globe Earth model. In other words,
Mm. Well,
yeah.
I'm too dumb to even speak on it, apparently, because either you're mad sophisticated or you're just saying wild things to me, because
Yeah.
I guess I don't know a dang thing. All right,
Okay.
man.
To show you, I guess to simplify it, can you see this plastic ball? Maybe you've seen
Yeah,
it
yeah, that's how
earlier.
you started the video. There was one.
Yeah.
Yeah. I
Yeah.
can
So
see it.
look. So can you see? Obviously, I have it at rest, right? As soon as I accelerate this in any direction, the ball reacts.
It
It,
sure,
it
sure.
moves, and it moves relative to the direction that the container moves. When it's at rest and I accelerate, the ball reacts. There's a reaction to the
Are
ball
you a
inside.
professor or something? Because you should be teaching.
Oh,
I
actually, I
mean,
do
you
go
are
to
right now, but
universities. If you check my channel, I go to universities and I do this presentation with the students. So
okay.
yeah, I do teach in public. So So let me share my screen real quick, just real quick, so I can show you what actual acceleration down looks like versus free fall. Because again, this simple accelerometer, the one I just showed you again, clearly shows that it reacts to acceleration from being at rest. So if we can understand that simple fact, let me show you this. Here we go. Oh, it's not here. Okay, this right here. So in this example here, the one on the right, again, you can see when as soon as I accelerate the container down, there's a reaction. The ping pong ball gets pushed down as well, because that's exactly what happens again with these accelerometers. When you have a buoyant object in water, that buoyant object is always going to react to the acceleration of the bottle. So the one on the right, you can clearly see the reaction to the downwards force or downwards acceleration. On the one on the left, it's free fall, which people believe because of gravity, it's accelerating down. But again, the matter is not reacting to a force or any acceleration, in other words. So reality, matter, shows us that a physical downwards acceleration of gravity doesn't exist. So it's literally the earth pushing up, and it's the earth that comes up to the object in free fall. And that's what's happening, in other words. So
I
again, you
feel
don't
like
have
I lost my mind. I just heard a whole science lesson. All right, all right.
no, yeah, but yeah, that is literally the number one proof that debunks the globe. And yeah, I mean, would you, if I was to ask you, what convinces you that the earth is a ball, or why do you believe that it is a ball?
I didn't put much thought into it, much like folks don't put a lot of thought into religion. Like I
Fair
wasn't
enough.
planning on addressing my beliefs in a flat Earth or a brown globe. Just to be honest with
Anti-globe
you,
channel.
yeah,
Okay.
I didn't know
Okay.
that was gonna be like question number one. And if I could just make a silly joke, just go with it. Who said the nerd doesn't get the pretty lady? You know what I'm saying?
Oh, right.
I'm sorry. I'm just playing around with it.
No, yeah, no worries, no worries. But oh yeah, I'm just a little surprised how you came across my channel.
I
But
did. I literally just typed open panel live streams. Got kicked off the rest of them. So here we are. I'll probably
okay.
leave just so as to not ruin your content because I'm me and I've been trying not to cuss, be very respectful.
Oh yeah, no
And
worries, no worries.
You can let them fly if you want.
No, yeah, but no, I mean, have you heard of this topic before? I'm pretty sure you've heard of flat Earth, right? Obviously, talking saying about Joe Rogan
I
and
think
stuff.
Eddie Bravo and Joe Rogan was going on and on and on about it. And everyone basically was like, "You're crazy."
Yeah.
And
So
honestly, it wasn't something I ever studied. You know, everyone's got the globe in their classrooms and stuff.
exactly.
Like, we never really questioned if the earth was flat or round. It didn't, like, really matter to day to day life, if that makes
Sure, sure.
sense.
Yeah, it's a typical response. I get it. Most people think that this doesn't really make a big difference, but in my opinion, it does, because if they can get you to believe something that's not true about your reality, something that contradicts the physical world, and they could get you to believe something else, then that means that you've been mentally handicapped in a way. So now you're willing to give your common sense away in favor of an authority. So now you're elevating other human beings on top of you, and that is literally the recipe for control. So
I'm
we're
gonna be
giving away
honest.
our, yeah.
I just want to find a wife and have kids. I wasn't worried about which shape the earth was. Like, I'm
Do you
just
like working a 9 to 5? Do you like paying taxes? Do you like paying a mortgage or rent? Do you like paying all that? Like, is that
I
is that
don't think
enjoyable?
anyone does, but I don't know how to get around that.
Well, it's understanding our reality and understanding that no other human being is better than us, and basically striving for equality, which would eliminate the whole government and the whole economic system. But we can't do that if people believe in magical forces that can do nature defying things. If people believe in all of these magical stories, fairy tale stories about outer space, that means they haven't developed mentally. And if we want to move forward in life and have a better life for everyone, we can't do that if people haven't developed mentally. So understanding the basic foundation of the earth and our reality, in other words, and and ourselves, it's only the start. In other words,
That's a
so
very sophisticated way to say I'm silly, and I appreciate it.
no, yeah. I mean, it's very important. I know when you really think about it, it does really go deep. It really affects everybody's lives, and it's the reason why people are so gullible. You know,
Well,
it's
can I
because people
ask
are
like
just
a complete
sure,
sideshow question?
sure, sure.
Did you watch the movie Wicked?
No, I heard of it, but no, I did not.
You should watch it. It's good.
Wicked. Okay.
I
Yeah,
liked
I've
it
heard of it.
anyways. A lot of
Yeah.
people talk bad about it, but I don't know why. It was a wonderful performance.
Yeah. What kind of genre is that movie? If I may ask.
It's a like musical,
You
right?
heard of the Wizard of
Theater?
Oz?
Yeah, it's like
Uh,
theater, right?
yeah,
Oh,
it's like
okay.
theatrical performance, lots of dancing and song. I thought it was
Okay.
good, but what do I know? I'm just some
No.
face tattooed fool learning about the Earth not being round.
Exactly. No. Yeah. I mean, again, I've been at it for. I mean, I came across this over 8 years ago. This subject, and I don't know if obviously you've heard of a flat Earth, but I don't know if you've ever heard that the false dichotomy. In other words, the Republican versus Democrat, right? The false dichotomy. It's the same thing with the flat Earth and the globe Earth. Why? Because the one thing that debunks the globe Earth, the upwards motion of the Earth, which again debunks the pulling force of gravity, motionless flat earthers are now believing that there is a downwards force like gravity. So they're keeping this idea of gravity alive, which is keeping the whole globe Earth idea alive. So the mainstream flat Earth that everybody has heard about, they all claim the Earth is motionless. So that's all controlled opposition.
So are you telling me there's no such thing as gravity? This is breaking
Yeah,
news.
yeah, there's no objects don't go move down to the Earth. No, it's the Earth that moves up to the objects. When you release an object like this into free fall, the object doesn't move down to the Earth. It's the Earth that moves up to the object. The object just simply loses momentum from the upwards motion.
Hey, I
So,
believe you. I've got
no,
no reason to not believe you. No, I'm just saying. It's
no, yeah,
I don't care if it's
yeah.
going up or down. I just know I'm falling. Either way.
Fair enough, fair enough, fair enough.
Well, hey
No,
man, thanks for letting me on the panel. You, sir, and kind ma'am, have a beautiful evening or morning, depending on what time frame you're in. And God
yeah,
bless if you believe in God. Otherwise, just have a wonderful day.
Yeah,
And
likewise.
I will continue to watch because clearly I'm too dumb to be a part of this conversation.
nah, trust me. I mean, we were all there, but hang in there. All
All right,
right, man.
take it easy,
Take
y'all.
care.
All
God
right,
bless.
Bye.
thanks. Yeah, God
Likewise.
bless. Yeah. All right, that was a cool conversation. Better than PK's, that's for sure. But yeah, I'm glad he short faced and everything. That just shows that not everybody is a troll and just trying to instigate. So
Or just a fake, like a bot account.
a lot. So no, I appreciate that. Um, let me see. We'll go on for a little more. See if there's anything that's worth. Let me see if I should not too dumb it on. We'll have to start somewhere. Exactly. That's what I was just telling them is that I believed everything I was told when I believed in the globe Earth. I literally believed in aliens from outer space. I believed, in space balls, and I used to fantasize about, what's outside in outer space and what it would be like to be in another planet. So I used to think about all that. So, we've all been there. Different levels of it, but we've all been there. We all believe everything we were told, and again, it just takes someone to be honest with themselves to realize and to realize that we are being lied to about the nature of the world, and the nature of our existence. At the end of the day, we didn't evolve from monkeys. That's for sure. We were created somehow. This is a creation that came from something else. So that realization to me was huge because I used to be kind of an atheist myself. Being a deep believer in outer space and all of that. I was a diehard believer in the whole heliocentric model, which by default made me want to believe in evolution. Right? I didn't 100% believe it. I was more like agnostic, but at the end of the day, I didn't accept that this was a creation either. So, level-headed William, do you think we should say the Earth system moves up instead of the ground, so they don't think the dirt is literally rising? No, yeah. I guess to be more specific, yeah, like the whole Earth system, the whole Earth as a whole is moving up. Yeah. So, so obviously the dirt, the Earth, I don't think it's moving itself either. Obviously there's something outside of it. The mechanism of the Earth's motion, obviously, it's unknown, but the Earth as a whole, has to be in motion. Otherwise, it wouldn't be part of the Earth, right? So yeah, everything that's part of the Earth and the Earth basically itself, it's moving together. The whole Earth system, I guess you could say. Yeah, definitely. I still think it was kind of funny that the guy just found this channel randomly by putting Open Panel live, right? That's pretty crazy.
Some people like joining random.
No, yeah, I do. Like just like isn't like it's not called a Russian roulette, but it's like a roulette thing. Like,
Omigo, Amanda just brought that up in the chat. She said that it would be a good idea, which I agree, if we just matched people like that and started talking to them about it.
right?
However, we would need to probably pre-record those because
Yeah,
I've heard
there's a lot of shit that
there's so much stuff that could just pop up and
Yeah.
get us a strike. So.
Yeah, that's true. It has to be pre-recorded. For
Yeah,
sure.
so we'll have to edit those scenarios out.
Yeah, that'd be kind of funny, and that'd be kind of fun at the same time. Actually,
Yeah.
getting the word out a
We
different
actually
way.
had nieces and nephews that actually just were on there to chat.
I hate to
random
say it,
people,
but most
so.
people that are on there are kind of on there to just troll. Let's be real. Like to get somebody actually to talk to, serious, it's kind of, be kind of difficult. But I mean, this last one kind of felt like that because he found us randomly.
Yeah.
Apparently.
I mean, they definitely be interesting. Because you're just gonna get the most random person anywhere, anywhere in the world, for lack of a better term.
Chat roulette, I guess. What it
Oh,
is.
chat roulette. Is that what you're talking about?
Yeah, I think that's what I meant to say. What did I say?
You said Russian roulette or something.
Something like that.
Yeah, but then I said
something
I said
roulette.
Amigo because I thought that's what you're talking about, and Amanda had brought it up in the chat.
Is that the same thing or is that different?
No, they're different.
Oh, okay.
The Amigo is what my nieces and nephews used to get on sometimes, so we would see.
Yeah.
And then the chat roulette is like similar,
But
just like another platform for it.
Okay, they're similar.
Yeah.
Pretty much. Okay, but they're different, obviously, but they're similar. Okay. No, yeah. New way to plan to see. Yeah.
Yeah, of course.
All right. Let me see.
once you make your way through all the rubbish, I'm sure you'll come across someone who's quote unquote normal.
Yeah. There was a couple of videos that we wanted to react to as well, but since we're already at the 2-hour mark, we'll probably do it on the next one. For now, I guess we'll see if there's any questions in the chat that people may want to ask before we wind down.
Is that what he's doing now? Nathan Opie is going to get all the people on Amigo if we don't get in there.
All right.
Yeah, those platforms are not a bad idea.
No, that's true. I actually never even thought of that. Like to be able to reach around the people. Another thing is that I've heard people saying that if you live stream vertically, right, not horizontally, vertically, that when people are scrolling like live streams, like on shorts, for example, like you go into the shorts tab and you just are scrolling live streams.
On YouTube?
Yeah, you're more likely. Supposedly, your channel's more likely to like get random people that are just scrolling through live streams when you're live streaming vertically. But again, I don't know if that matters if your channel's being shadow banned. I don't even know if that would matter, if that would go around the algorithm of that. But I've heard that could increase your live viewers or reach, different people, I guess, that are just randomly scrolling through like the shorts lives, live streams. So maybe try it in the future. We'll see. Who knows? Maybe we'll reach new people, JC Nathan Oakley goes on Omegle from time to time and tells people how Earth is measured flat. I see.
Yeah.
No, yeah. I mean, again, trying to reach new people. Again, that's the next step. I mean, once you realize the biggest lie on Earth, what do you do with that? You share it with others. I mean, what else are you gonna do? You're just gonna stay quiet when you figured out the biggest lie on Earth? Like, if you just stay quiet, then damn, that says a lot about you. I mean, it's cool, right? It's your will. Everyone has their own free will at the end of the day. And if you're one of the people that would rather just stay quiet and sit back and see what happens, and that's fine. But in my opinion, it's like when you learn a new trick, in other words, or you learn a new joke, right? Or something, you want to share it, especially if it's something big or something fun or something, something that made you feel good. Like, you want to share that, naturally. So for me, realizing this lie, the biggest lie on Earth, what the Earth is, and the fact that the objects don't accelerate down in free fall, it's literally the Earth moving up. Like, realizing that, to me, is like, it brings in so much clarity, not only that, like, it just, again, like, it just makes me confident in my common sense, like understanding things for myself. It's just a good feeling at the end of the day.
Yeah, and it's best to reach the new people too, because again, with with all the flat Earth gurus, I guess, a lot of flat earthers are already stuck in their mindset. So I would say that whatever, if they're flat earthers, if they're honest, they'll get this. And you don't have to try to reach out to them and try to show,
Convince them, basically.
Yeah, reaching new people is the ultimate goal, I believe, because it's about spreading it out there. If flat earthers don't understand it or just deny it, well, then that's again a you problem, and it's just about reaching more people.
You move to the next. You move on to the next.
It's pointless to waste your time on people that are already stuck in their mindset.
Yeah.
It's not about trying to convince anybody. Reality just is what it is. You can deny it. You can, I mean, if even again, it's not just about denying, because I get people don't understand it, which again I find that hard to believe as well, because it's very simple.
It is.
Especially the way everyone has broken it down. It's very easy to understand. And again, it doesn't get any easier than understanding
cause and effect.
Yeah,
that's what it comes down to. It's cause and effect. Acceleration requires a cause, and acceleration has effects. So again, claiming acceleration in free fall, you have no cause, you have no force, and you have no effects, you have no displacement. So it's literally that simple. It's literally that simple. So
and I always go back to, the more people talking about this, the better, because the way we all can articulate things is different, and the way someone can word something can resonate with someone when it didn't resonate before.
Mm-hmm. Yeah, exactly. It's a call from a higher power to spread the word and to try and help raise the consciousness of our humanity. Exactly. I actually feel that way too. Like, it sounds kind of cheesy, but like, with great power comes great responsibility, mm-hmm. right? And knowledge is power. Understanding things, for yourself is empowering at the end of the day. That's what I was saying, like, just a second ago, how understanding reality for myself, it just gives me confidence, because it is empowering, and sharing that with others, empowering other people is going to be how we move forward with this. Again, using knowledge and twisting it to take advantage of people, that's what psychopaths do. That's what liars do. And that's exactly what these people are doing, all their representatives, the governors. Maybe they're not doing it directly. Maybe they're just puppets themselves, right? Being controlled. But at the end of the day, they're still selling out at the end of the day. They're going against their own morals. They're fucking over a lot of people regardless. So again, understanding things for yourself, empowering each other is what's going to move this topic forward. And eventually, we'll have equality. Again, it starts in the mind, at the end of the day. Judgment starts by judging yourself. Allowing another human to have authority over your life proves a weak mind. Exactly. again, have authority over your own mind or somebody else is, at the end of the day. And if you don't have authority in your own mind, you don't control your own mind, then someone else is going to control it. It's just how it is, you know. Again, gaslighting people from a very young age, making us doubt our common sense, in favor of an authority. This whole hierarchy structure, even in the school systems, all the way to we're adults, even in the home, it starts. This whole Irish, it's literally just to mold us. It's to change our perspective, to deny our common sense and everyday experience. It's to just obey authority, at the end of the day. So again, people are not thinking for themselves. In other words, they're just being an NPC. You're being programmed. You're not thinking for yourself. Your thoughts are not your free will at the end of the day. Because the only way to have free will is to have a full understanding, or to have an understanding, in other words. If you don't have an understanding in what you're participating, then you have no free will. It's literally that simple.
And for those that say like, well, how does it matter? It doesn't matter. It doesn't change my life. Well, it does, because you're not thinking for yourself. So what kind of decisions can you make? And if you have children, you're just going to teach them how not to be able to think for themselves, and just to appeal to authority, and anybody in higher authority you have to respect. And again, people use like a higher authority as like a consequence to children and stuff like that. Like, oh, well, if you don't do this, I'm going to go tell someone. Or, like, again, it's just, you're not even, your own kids don't even see you as like a decision maker at that point. They don't see you as the leader you're supposed to be.
Right, because you lead by example. At the end of the day, you don't lead with authority. You don't lead by force. In other words, you lead by example. You don't lead by dictating. In other words, you lead by example. At the end of the day, so. And the only way to be a leader is, again, to have your own discernment, to think for yourself, and again, control your own mind. That's the only way to be your own leader, and again, that's the only way to lead others is by example. And then others can join, or, they can just deny reality if that's what they choose. Get your children out of public schools, show them real love at home. The lack of love is the real problem with humans. Yeah, I agree with that.
I couldn't agree anymore.
That is true. I think showing compassion, it's, again, at the end of the day, being human, means, in my opinion, it's to have emotion, it's to show compassion. That's what makes us human, in my opinion. That's where the word, humane comes from, from being human. What does it mean to be humane? It means to be kind. It means to be compassionate towards others. To show love rather than hate, So yeah, I do agree that the lack of love, the lack of, compassion, can lead to not living a good life at the end of the day, Why would stationary require acceleration? The stationary Earth requires acceleration because if you believe the Earth is stationary right now, for example, and you're holding an object, at rest right now, for example, and you release that object, you have to believe that that object went from being stationary when you're holding it to moving down towards the Earth. In other words, accelerate down towards the Earth. So that belief is no different than what Globe Earth claims with gravity. When you hold an object and it's at rest and you release it, gravity pulls it down towards the Earth by some magical force. And again, it's called a magical force because there's nothing that can be measured that's actually in motion that's pushing that object down. So there is no push in free fall. There is no pressure. The matter in free fall, for example, the water inside this container, the pressure that's in it right now, is when I release it into free fall, that pressure, that force completely vanishes, which is what you would require if there was an acceleration down, because acceleration requires a force. Not only that, acceleration will also cause displacement of matter, which doesn't happen in free fall. So the stationary, again, requires a downward acceleration because if the Earth's not moving up, to the object, then it's the object that has to be moving down, which means it has to accelerate, which can easily be debunked by any accelerometer. Not only that, any accelerometer would show that the force is up. and it's only present when connected to the Earth. So the upwards motion of the Earth not only debunks the motionless flat Earth, but it destroys the whole heliocentric model. So the truth is important in a world where there is more deception and manipulation than there is honesty and transparency. I know that is true, obviously. And obviously, when you're talking about truth, obviously, we're talking about objective truth. Because at the end of the day, objective truth is what's going to bring everyone together. It's the common ground at the end of the day. It's what we can all prove to each other and know what's fact, in other words. And yeah, in a world where so much dishonesty and manipulation, staying true, it's just rare. So yeah, I mean, it's important. So yeah, it's important to represent the truth once you figure it out. Newton's apple had mass and fell when the stem couldn't hold it anymore. That is not a force pushing it or pulling it down. Is that a question? That is not a force pushing.
I'm replaying your explanation. I'll get back to you.
I mean, why? I would say to Tom Buddha's, why did the apple have weight to begin with if it doesn't have a force in free fall? Tom Buddha's, why did the apple fall from the branch? In other words, why did it have weight when it was connected to the tree? If it wasn't a force giving it its weight that made it snap from the branch, what was it? Because if you're saying that it is a force, and when that gave it its weight that made it rip from the branch, what happened to that force in free fall then? It was there present when it snapped it from the branch and then it just vanished, but it's somehow still able to move it down and accelerate it down. And then once it hits the earth, the force comes back again. So what is this gravity force that's not a force that still accelerates objects? Like, I don't get it. Everything finds equilibrium. Well, why? You're claiming that objects move and find their equilibrium. What's causing the movement of the matter to find its equilibrium? I guess that would be the question. Tom, what's the cause that makes the matter finds its equilibrium? If it's not a force, what's the cause? Define equilibrium. I'm assuming he's probably talking about RDD. Execrate. Good point, Execrate. How does something dead and inanimate find anything? Exactly. So again, what does it mean, Tom? So if you think that matter just finds its equilibrium and basically sorts itself, you believe that inanimate matter can move itself without an external cause. I guess that's where I'm getting at. what's the cause that makes the inanimate matter move and orientate itself? I guess that's the question. I'm trying to be direct. I'm trying to like narrow it down. Like, is it something external to the matter that makes it do that, or do you think it's just part of the matter that just automatically does that?
V. Thomas, yeah, I mean, it's a hard truth, right? I mean, there are some people that will never think for themselves. They're just going to do what they're told. They're never going to go against the grain. It's a hard truth to accept. You can only do so much to help people.
I mean, that's what they're claiming. If it's not an external cause that makes matter move, then they're literally claiming, that matter just has that in it. So yeah, what gives the matter, its wants and needs, basically, and its motion. It's want to move up and down if it's more dense, right? And up if it's less dense.
They're still human beings, yeah, of course. And it's just they're non-participating. Of course, they still have feelings. Their lives still matter. No one's discrediting, that. It's just some people will never think for themselves. Some people will never discern for themselves. Some people will never progress. It's a hard truth.
All right, let me see this one more. RDD requires the belief that inanimate matter moves by itself. Nonsense. Exactly. Literally. You have to deny that a force is required not only for acceleration, but even to just have constant motion, in other words. But, all right. I think that's going to have to be it for this one. Let's see. The fact of the matter is that motion only exists through applied pressure. Find the applied pressure and move on. Exactly. Again, you can only have motion and acceleration through applied pressure. Exactly. So if there's no pressure, applied pressure in free fall, doesn't take a genius. There's no displacement. There's no applied pressure. There's no gradient. There's nothing. No effects of acceleration whatsoever. That should be more than enough. But yeah. Okay, I've been in this for almost 10 years. It's flat and stationary. If I had seen a ship Reaper when I quit drinking in 1983, I'd be coming up on 43 years for that. Well, again, it's not flat or stationary because the Earth has mountains and valleys. So the definition of flat doesn't fit the Earth. The correct term would be level because level is an orientation and Earth does have orientation. And in order for something to have orientation, it requires motion, it requires a force. You can't have orientation of up and down without a force. And the Earth does have orientation. It gives us our up and down. It's only when we're connected to the Earth. If you're in free fall, if you're in a parabolic flight, for example, in a 0G plane in free fall, you cannot tell what's up from down. You have no orientation. There is no force, vertical force acting on you in free fall. Otherwise, you would have orientation relative to that vertical force, but it's not there in free fall, showing there is no physical downwards acceleration, debunking the globe Earth and also debunking the motionless flat Earth. Because again, you require a physical downwards acceleration just like the globe Earth, which doesn't exist. The vertical force is only present when you're connected directly to the Earth, when the Earth is literally pushing up against you. That is when we experience orientation, which makes the Earth level. Again, level perpendicular to the vertical, which is the force of the Earth, which is a push, upwards motion, in other words. So, all right, that's going to be it for this one. Any last words? No, you're good.
We're all good.
Yeah, I think we got most of the comments. So, yeah, thanks again for everyone that joined. We'll go over the videos that we wanted to go over in the next one. So, that'll be that. And yeah, from now on, I'm going to have the chat open from the start. Unless I have a presentation that I really want to present, then I'll hold on till after the presentation and then I'll open up the chat. But most likely from now on, the link's going to be available from the start for for anybody that wants to join the chat, the panel, or and wants to have a conversation with me. If you think you can prove the globe Earth or the stationary flat Earth physically, please come on. I want to hear your explanations, your thoughts, your experiments, your line of your reasoning, your logic. I really want to understand where you're coming from. If you believe the Earth is a globe or a flat stationary plane, or any other beliefs again about this objective world. Again, so just a heads up. The panel is always open, and if anybody wants to join, especially when we're doing these late night streams. Obviously, when I'm out on the streets, that's different. Not only do I not have my laptop with me to be able to take calls, but I'm also there to speak to people in person. So yeah, the open panel is always going to be there for these late night streams when we're at home. So yeah, I just wanted to let everybody know that. So yeah, again, thanks again, and yeah, we'll see you on the next one. Peace.
Take care.